What's poppin', dogs? Mr. Allen here, writing some equations of lines in this video, a key concept from Algebra 1 that you're going to use in every math course in high school, all the way up through AP Calculus. So let's get it down, Pat. First thing here, we're going to find the slope of line AB. And we have points A, 6, 1, and B, -2, 5. So those are the coordinates of points A and B. I think it'd be helpful if we wrote down the slope formula first. It uses a fancy, bougie M right there for slope. And it's the change in y over the change in x. When we say change, we're talking about subtraction. It's often written as y2 minus y1 over x2 minus x1. Now, the order doesn't really matter as long as you are consistent in numerator and denominator, okay? So whether these are x1 and y1, x2 and y2, or vice versa, either way is cool as long as you are consistent in your formula. So we have x1 here, y1, we'll just do it because that's the order that I wrote it, right? x2 and y2. And now let's just go ahead and plug this into our handy dandy slope formula. So check it out. We got, let's see here, y2, so that's 5, minus y1, which is 1, over x2, which is -2, minus x1, which is 6. And now let's simplify. We got 4 over -8, so we got -1/2. Once it's all, don't forget this fraction there, -1/2 once it's all simplified. There we go. Now remember how I said the order doesn't matter as long as we are consistent? Check it out. What if we swapped this? Because I know a lot of people, they like stress over like, oh God, what order was it, whatever. Check it out. If I swap these, okay? So I'm going to do essentially y1 minus y2 now over x1 minus x2. Let's see if we get the same result. So I have y1, which is 1, minus y2, which is 5, over x1, which is 6, minus x2, which is -2. We're going to change this to addition now because we're subtracting a negative. I get -4 over +8, which is, oh my goodness, -1/2. If you swap in the numerator or denominator, you'll end up getting the same slope, but the opposite sign, okay? So that's what happens there. But either way you slice it, as long as you're just consistent from the ordered pair, these ordered pairs line up, these ordered pairs line up, right? As long as you're consistent, you're good to go, okay? So now let's write an equation of a line, and then we're going to put it all together in this third example here when we're given 2 points and we got to write the equation of a line. So this one over here says, write the equation of a line in slope-intercept form that contains the point -8, 3 and has a slope of 3/4. So let's write down slope-intercept form here. That's y equals m, fancy m, x plus b. And what are all these parts of this equation here? Well, we already said that m was our slope, so we'll say that right there, slope. And then what is the b? That is my y-intercept, okay? So it's a point on the line, but a specific point. It's the y-intercept on that line. The y and the x are just going to remain y and x. They're going to remain our variables, okay? But we are actually going to be substituting some numbers in for them through the process and then writing our final answer, okay? So let's do that. Well, what do I know? I know that we have the point -8, 3, right? I don't know my y-intercept, which is the point that I really want, but I do have a point no less, right? So if I were to say that this is my x and that's my y, right? It's an ordered pair, x, y. Could I substitute x and y in to this equation here? And then isn't this right here m, right? I have 3 out of the 4 pieces. If I plug those all in, couldn't I then solve for b? Yes. And if you're like, whoa, what? Let me write it down so you're not just trying to visualize it all in your brain. So we got 3 for y. My m is 3/4, scary fraction. My x is -8. I'll throw that in parentheses here. And now I have b. I have one variable, and I got numbers. I can solve that, right? I can solve this away. So we've got 3 still over here. Let's clean this up. That's -24 over 4, which is -6. Or you could have said -8 divided by 4 is -2 times 3 is -6. Either way you slice it, good to go. Plus b. And now if I add 6 to both sides here, so we're going to add 6 as I'm running out of room, add 6, I get b. I'm going to throw this up here. We've got m is 3/4. It's part of the problem. And we got b is, then if I add 6, I get 9. Those are the 2 pieces to the puzzle that I need to write this equation in slope-intercept form. So now what I'll do is I will write y equals my slope of 3/4, x plus 9. And that is my final answer here for the equation of a line in slope-intercept form that contains this point and has that slope. Boom. That's it. I need a point, I need a slope, and I can get my y-intercept from that information. All right, so that's kind of like a mid-grade one. Sometimes they give you the slope and the y-intercept, or sometimes they give you the slope and they give you like 0, 5, and that's just your y-intercept in disguise. They don't outright say that it's the y-intercept, but you have to see that it is because of the coordinate. But over here, this is really where it becomes, I would say, the most time-consuming process of writing the equation of a line when you're just given 2 points. We got C and D, right, on the line CD. So I got to write this in slope-intercept form. Well, the first thing I got to do here is I'm going to find my slope. So let's use that slope formula to figure that out. So I got M, fancy M that is, equals, we're going to do change in y over change in x. And again, it doesn't matter which ordered pair you start with as long as you're consistent in the numerator and denominator, okay? So we'll do 10 minus 2. I'm doing that just because I figured it will stay positive then in the numerator. We'll start out with that. We'll see. So 10 minus 2, that's y2 minus y1, over 1 minus negative 3. 1 minus negative 3. All right, so we did change in y over change in x. And I started with D here. That's the ordered pair that you see there first. And then C, that's the ordered pair that you see second, okay? So let's simplify this now. I've got 10 over 2 is 8. And then we got addition happening there because we're subtracting a negative over 4. That's going to equal positive 2. So my slope is 2. And what I like to often do here is I write down like a little spot to do this, where I say, okay, here's where my slope's going to be. Let's pop it right there. And then my B value, okay? So I throw like a little, almost like an answer blank for myself so that I remember these are the things that I got to get, right? So 2 is my slope. All I need now is my B value, my y-intercept. Well, how do I do that? Well, if we take our slope-intercept form, y equals mx plus b, y equals fancy m, x plus b, and I just plug in the stuff that I know, I can actually solve for b. I got a couple options here on this one. I can use either point C or point D for my x and y, and it will work out correctly as long as I don't make any mistakes in this whole process. So you can pick either one you want. I'm going to go with point D because they're both positive numbers, right? I'm usually going to try to avoid negatives just so I don't screw something up. But here we go. We got x here. I got y here. Let's plug them in. So y is going to be 10. We've got m, which is 2, x, which is 1. That's easy to work with. So that's 2. So we have 10 equals 2 plus b. We'll subtract 2, and we get b equals 8. So are we done? No. A lot of people end up doing it, they're like, oh, cool, I'm done. Awesome, great, figured everything out. You didn't write the final answer, bro. We got to write the final answer. Y equals 2 is my slope, x plus 8. Bingo, bango. Toughest problem done right there, okay? Write an equation of a line in slope-intercept form that contains these 2 points here. Right? There are some other variations. I'll get into some of those ones as well as we review some Algebra 1 concepts where you have to write it like a perpendicular to a line or parallel to a line through a particular point, maybe even the perpendicular bisector of a segment. Oh my goodness, we got to get midpoint involved. But that's enough for this video here, guys. I hope you enjoyed it. If you have any questions, pop it in the comments. Requests for other videos, pop it in the comments. Otherwise, have a dope day, and thank you for watching.